Hello and welcome back to my channel. Today I'll be solving the simple issue of replacing my TV remote by going out of my way to design and 3D print a new case for it. Stick with me till the end and find out if it was all worth it, and maybe learn a bit about the challenges we can face when undertaking a task like this. I start the process as usual with measuring my broken remote and writing down all the dimensions on a sheet of paper. To do this I have to take apart the remote, and it's a little tricky since I have super glued it shut in a previous repair attempt. So I take a screwdriver and try to push it open. I don't really care about breaking it since I'm going to be reprinting it anyway. After I manage to pry it apart, I carefully measure all the button sizes, which ends up being quite a tedious task. I'm going to fast forward to this part since you don't really need to see me measuring a bunch of holes. The general idea is that I take a lot of measurements, and sometimes I will measure an entire cluster of buttons as well, and the gap between them, so I can then calculate the button size. This should in theory end up being more precise. Next, I have to take the circuit board apart. To do this, I need to carefully push the battery terminals out as they are rigidly attached to the board. You can see one of them is broken and soldered to the board with some wire. Like I said, I already tried repairing it once before. I will need to solder this terminal back to the board before I finish this, so I better make sure I don't lose it. Now to start drawing it in CAD. I start with the top half, the one with all the buttons, since I believed at the time that this would be the hard part. Nothing too complicated here, just position all the buttons to the measured coordinates, give the part some thickness, and cut holes in it. I choose to print this flat on the bed without supports and leave the complicated printing to the other half. I need to make sure I increase the hole size a bit to account for the tolerance. Somehow they always end up being a lot smaller than what I designed, and the curvature of the surface as well. And also completely eyeball the size of this bump near the volume keys, which I have to say was a pretty good approximation considering I have not measured this at all. After I'm done with the general shape, I import it in Cura, my slicer, to check that it actually fits within my bed, and also do a test print, because I was not all that confident in the measurements I made. So I start the print and stop it after 2 layers, and I end up with this flexible draft of the part with all the holes in it to check against the original layout. As you can clearly see, it does not match perfectly, so I align it and measure the differences and feed the information back into CAD. Really happy I tested this out since it saved me 4 hours of printing. To continue, I have to model up the circuit board just to check that we have enough clearance. Then I can start designing the bottom half. I outline the general shape and create a multi-section for a fine transition. For this, I try to keep enough clearance to the batteries and copy the general shape of the remote just so that it would feel nice in my hand. While I do this, I like to take the time to remind you to subscribe to my channel if you haven't already, and leave a like if you are enjoying this video. Your support means a lot both to me personally and for the YouTube algorithm. And of course, don't forget about the finger channel. Next, I cut the hole for the batteries. Here there's a lot of tedious modeling, but generally I try to copy the same features on the original remote, except for the clip, which in my experience can end up being quite brittle with this thickness and can easily break. So I opt for using a screw joint instead. For the resting surface, instead of going flat, I opted for the angled surface. This would be easier to print without supports and will help with self-centering. On this tab, I will have the screw. And in this hole, we will have another tab that keeps it from popping up. This is just basic battery cap science here, nothing too fancy. Talking about screws, I quickly model some hexagons to add some captive nuts later, since I'm not confident enough to go for clips to join the two remote halves together. I patterned the features along the edge of the remote, and since I'm using Boolean operations for this, I will model the clearance hole for the lower half in the same solid. This will allow me to adjust the size of the holes easily in the future. I would just need to update one of them, and all 6 of my screws will update in both halves of the remote. At this point I painfully realized that I will need 3 different lengths of screws, which I don't have at the moment. Also at this point I realized that I don't have enough space for my screws, and I end up making the remote a bit wider. The final touch is the clearance cone around the LED. The original remote did not have this, but I went a different way with the design. And it's ready to print. Fingers crossed now. The top half prints rather well, with no issues. And I'm actually quite impressed that I didn't get any warping, considering it's a very flat part. The bottom half is a bit tricky as it has a lot of supports, but most importantly it will have this hole for the battery cap, and I don't want to fill that with support as it would be almost impossible to pull out. And to do that I need to add a support blocker. After I position the blocker correctly, I make sure that it's set to don't support overlap, so that it skips the support material inside the hole where it would be inaccessible. And then this one should be ready to print as well. This part ends up taking 12 long hours to print, but I am extremely happy with the result. Next step is to add the captive nuts I mentioned earlier. To do this, I add a little bit of super glue to the cavities and heat up a nut and push it in. This melts the plastic and creates a very tight grip around the nut. After it cools down, I use a screwdriver to remove the screw and repeat the process for all the nuts, including the battery cap. I'm quite happy with the final results. Afterwards, I give it a quick coat of paint, and while it dries, I need to do something about the screws. I mentioned earlier that I will have to use 3 or 4 different lengths of screws, and that is really problematic, since each screw has to be an exact size. Finding a 5.8 or 3.2 exact size screw will most likely be impossible, so that means I would have to take some existing screws and cut them to length. I measure each screw and use a marker to indicate the general cut location, and take them out back and use an angle grinder to cut them to length. Unfortunately, the cuts are not all that precise, so I need to grind them down a bit, but this way the length will be very precise and the cutting line will be straight. Now I have to solder the broken battery terminal back to the board using the copper wire. I don't have to use the wire, but I believe this is easier to do, and it will also help me assemble it easier. More on this later. Before I start soldering, I use a bit of flux on the copper wire. This will remove the oxidized layer on the surface of the copper and will help the soldering material stick better to the surface. I wrap the wire around the broken bits of the terminal, pour some molten tin over it, and it's a quick job well done. All that's left to do is to assemble it. Should be easy, right? Well, it turns out that I didn't account for the copper wire's soldering nugget thickness, and it was really hard to fit the remote together. As it turns out, I didn't take into account a lot of things, like space for this chip over here at the back, or these protrusions at the back, or these clips for this button cluster. After hours of trying to fit them, I ended up drilling into the part to create clearances for everything, and finally managed to close up the remote. So now I load up the batteries, cross my fingers and hope for the best. And success! After 2 days of printing and hours of fiddling with clearances, I finally have a working remote. Oh, and I almost forgot, need to close this up with a battery cap. This is almost an exact replica of the original one, except for the mating surface and the screw hole. This fits quite nicely in here and has a smooth look to it. So that is how I spent 3 days of my life designing and printing a replacement remote for my TV. Probably would have been better off just buying a new one, but honestly I was curious to see if I can actually pull it off. So let me know what you think in the comments below, and don't forget to like and subscribe to see more videos like this. Until next time.